Good afternoon, dear students. I hope you have understood the previous lectures on homogeneous and linear differential equation. And today in this video lecture, I am going to discuss about the exact differential equations. So let us begin. So let us at first see what is an exact differential equation. So here is a simple definition that if mxy and nxy are two functions of xy, which I have denoted here, then the equation of this form is said to be what? Exact differential equation, provided it satisfies the condition partial derivative of m with respect to y is equals to partial derivative of n with respect to x. So if you see this and this, though I didn't discuss about partial derivative, but still I will simply say this much only, that in partial derivative, suppose this is the partial derivative of m with respect to y. So since it is with respect to y, x will remain here constant. Okay, when you will take the partial derivative of any quantity, any function with respect to y, then x will remain constant. If you are taking the partial derivative of another function, suppose here n, with respect to x, then y will remain constant. Okay, it's very simple to understand. If you are taking partial derivative with respect to y, then x will remain constant. If you are taking partial derivative with respect to x, then y will remain constant. So that's why here I have written that where partial derivative of m with respect to y denotes partial derivative of m with respect to y keeping x constant. And similarly here also I have written the same thing. Here we have kept y constant. I hope this must be clear to you. To understand this exact differential equation, let us try to solve a very simple example. So if you see this question, we have got this question. Now let us at first check whether this equation, differential equation, is in the form of an exact differential equation or not. So if you see, this is some function of xy with dx, and this is some function of xy with dy, and this is equals to 0. So it is similar to what? It is just similar with the format of exact differential equation that we have just seen now. So this is the format of exact differential equation and it is matching. Okay, so in the solution part, we are just going to take this as m and this as n. So we'll be writing here m is equals to what? 5x to the power 4 3x square y square minus 2xy cube. Similarly, we have n is equals to 2x cube y minus 3x square y square minus 5y to the power 4. Okay, so this is what m and n here in this equation. I'm just rubbing this. Now what is the next thing that we are going to do to get the solution of this exact differential equation? We will be taking the partial derivative of m with respect to y. Okay, if you remember the condition. So partial derivative of m with respect to y will be equals to partial derivative of this function, that is 5x to the power 4 plus 3x square y square minus 2xy cube. I will just multiply this partial derivative with each of this term. So by doing that, I will be getting what? 5x to the power 4 plus partial derivative with respect to y 3x square y square minus partial derivative with respect to y 2x y to the power 3. So I've just separated the terms. Now if you see in the first term, since 5 is a constant, and as I have said, when you will be taking partial differentiation with respect to y, x will remain constant. So here in the first term, x is also constant. So partial differentiation of a constant is always a 0. So first term will be 0. So let me go to the new page. So let me at first again write the same thing here, is equals to partial derivative of with respect to y 5x to the power 4 plus partial derivative with respect to y 3x square y square minus partial derivative with respect to y 2xy to the power cube. So I've again rewritten this, okay, so that you can understand the next step easily. So the first term will be 0, as I have already said. What about the second term? So here x is constant, 3 is constant, okay. So this term is constant here. So only we are left with y. So it will be 2 into 3x square, okay, and this will be y. That is, you must know the formulas. So I am directly applying here the formulas. Again here 2 is constant, x is constant, so that will come outside, and what is left? 3. So it will be 3 y square. So we are finally getting what? 2 into 3 is 6 x square, y minus 2 into 3 here 6 x y square. So this is what we have got in our final answer, okay. If you simplify it further, you will be getting 6xy minus, into x minus y, okay. Now let us try to take out the partial derivative of n with respect to x. So let me write the function n here. What was the function n? It was 2x cube y minus 3x square y square minus 5y to the power 4. So this can be further written as what? Again I will just separate the terms in this way. I've just separated the terms, okay. So in my next step I can write what? Here, since we are taking the partial derivative with respect to x, so our y will remain constant. So if you see here, 2 is constant and y is constant. The only variable is x cube. So the partial differentiation or simply differentiation of x cube is what? 3x square. And here in bracket, the constant part is 2y. Similarly, if you see the next term, that is 3x square y square. So y square is constant, 3 is constant. I can take it outside, 3y square, and what is left? X square. So it will be 2x, and the last term is y to the power 4. I have made a mistake here. Let me correct this. It is actually x, but I have written by mistake y. It is x. So here y is constant, 5 is also constant. So differentiation of a constant is 0. So this term will be 0. So we are having finally what? 3 2 is 6 x square y minus 3 2 is 6 x y square, which is equals to this, okay. So let this be the equation 1 and let this be the, this can be further written as 6xy x minus y, and let this be the equation 2, okay. So from 1 and 2, we get what we get? That partial derivative of m with respect to y is equals to partial derivative of n with respect to x. So this condition is satisfied. It means the equation or the problem that we have got is exact differential equation. Now the next step is to write the solution of this exact differential equation. So how to proceed for that? Now we will write now integration of m dx. Here y is constant, remember, y constant, plus integration terms of n not containing x. So only those terms of n we will be taking which do not contain x, and that only will be integrated here. Okay, and it is dy is equals to c. So this is the solution of an exact differential equation. Always remember, okay, and please note down this. So I will just put the value of m and n here. So this can be further written as integration. So what was the value of m? It was 5x to the power 4 plus 3x square y square minus 2xy cube. This whole thing bracket closed, and dx plus, here we will be having what? Terms not containing x. Where? In n. So I will be writing at first n here. So n was here 2x cube y minus 3x square y square minus 5y to the power 4. So if you see, the first term contains x, so we will not take this. The second term contains x, we will also not take this. So we are just going to rub this. We don't need these terms, okay? So I'll be just rubbing this, and I will be simply writing what? Minus 5y to the power 4. So here I am writing here minus 5y to the power 4, and this into dy equals to constant c. Now what we are going to get next? If you integrate this, here our y is constant, remember. So if you integrate the first term 5x to the power 4, we are going to get what? 5x to the power 5 by 5, okay, plus here our y is constant, so 3y square will come outside, only x square will be integrated, and it will be x cubed by 3 minus, here again y is constant, so 2y cube will come outside, and only the term integrated will be what? X. So it will be x square by 2 plus, here if you see, so minus, okay, let me write minus in bracket only, 5, and integration of y to the power 4 will be what? To the power 5 by 5, okay, and this is equals to what? C, some constant c. So if you see, here 5 cancels out, here 3 cancels out, here 2 cancels out, and here again 5 cancels out. So this can be further written in a simplified way. X to the power 5 plus x cube y square minus x square y cube minus y to the power 4 is equals to the constant c. So this is what the solution of this exact differential equation, okay? So this is how we solve an exact differential equation. So if you can see these steps, you must be aware. At first you have to check the equation, whether it is an exact differential equation or not. So this is the procedure you have to follow for solving an exact differential equation, if you get. Okay, let us try to solve another example. Solve y square e to the power x y square plus 4 x to the power cube dx plus 2xy e to the power x y square minus 3y square dy is equals to 0. So this is the question we have. Okay, now let us see the solution for this. So here you can see this is m and this is what, n. So I will be writing here m is equals to y square e to the power xy square plus 4x to the power cube, and n is what, 2xy. I have missed here something perhaps. No, it's okay. Okay, e to the power xy square minus 3y square. Then we will be taking the partial derivative of m with respect to y. So when you will take this, y will remain constant. So let me first write the function, that is y square e to the power xy square plus 4x cube. So here our x will remain constant. Okay, so this will be equals to y square partial derivative of with respect to y e to the power xy square. If you remember, this is AB form. Okay, partial differentiation of AB. So at first I will take a outside and I will differentiate b, and then again plus I will take b outside and I will differentiate what, sorry, it's partial derivative. So I will do the partial derivative of y square with respect to y. And if you see this term here, this term contains what, x, which is constant for the partial derivative with respect to y. So this part will be what, simply 0. I'll be writing. So this can be further written as, this is y square. Okay, so this can be further written as y square. So partial derivative of this, here x is constant, remember. Okay, it will be e to the power xy square, and again we will be differentiating this, it will be x to y plus, if you see here, e to the power xy square, and partial derivative of y square will be what, 2 into y. So this will be equals to, if we just rearrange it, we will be getting 2xy cube e to the power xy square plus 2y e to the power xy square. Okay, so this is what we have got. Let this be the equation number 1. Similarly, the partial derivative of n with respect to x will be equals to partial derivative with respect to x function of n, which was 2xy e to the power xy square minus 3y square. So this will be equals to what, if I do the partial derivative here. Okay, so it is of the form a and b. So I will be taking the form. So let me take at first a outside and differentiate the b, that is e to the power xy square plus e to the power xy square partial differentiation with respect to x. Here it will be 2xy, and this term will be 0. That is, the last term will be 0 because there is no x term. Y is constant here, 3 is constant, so differentiation of a constant is 0. So we have put here 0, Now further we'll be getting what here? 2xy, and partial derivative of this will be what? E to the power x y square, and again you differentiate this, it will be, since we are differentiating with respect to x, so we will be left with y square, plus here again e to the power xy square, and partial derivative of this will be what? Here 2y will be constant, and partial derivative of x with respect to x will be 1, so that is the thing. Now here if we just do it further, we will be getting 2xy cube e to the power xy square plus 2y e to the power xy square. Let this be the equation number 2. So from equation 1, from 1 and 2, we get that partial derivative of m with respect to y is equals to partial derivative of n with respect to x. So it is an exact differential equation. Okay, so we will be approaching to the solution part of the differential equation. So now integration of m, and here y is constant, dx plus integration terms of n not containing x dy is equals to constant c. So if we put here the value of m, we will be getting what? Integration y square e to the power xy square plus 4x cube bracket close dx plus integration 2xy e to the power xy square minus 3y square bracket close dy is equals to c. So here if we integrate, what we will be taking? Y as a constant. So integration of e to the power xy square will be what? So y is constant here, it will come outside, and integration of this will be this. Okay. Similarly, integration of this will be what? 4x cube by x to the power 4 by 4 plus integration of this will be here. We will not take the term containing x. Okay, so this will be 0. We'll be taking only this term. So we'll be writing here what? So if we integrate this, we'll be getting minus 3y cube by 3, and this is equals to c. So this cancels out, 4 cancels out. What is our final answer? Y square e to the power xy square plus x to the power 4 minus y cube is equals to c. So this is the solution of this exact differential equation. So thus I hope that you have understood how to solve a exact differential equation. So today I am ending my lecture here only, and I will soon give you assignment based on this exact differential equation. So that's all. Thank you.